We already know how to calculate the angle between two vectors using the inverse of the cosine of the dot product of the two vectors. Knowing that the rows 1, 2 and 3 of a transformation matrix represent the x, y and z local axis of the node, we can easily figure out whether a node is facing another with a certain axis. Let's create a teapot and a teacup by removing some of the parts of the teapot. Let's call this second object cup01 and try to calculate the angle between the local x-axis of the teapot and the direction defined by the two positions, the vector from position 1 to position 2. Variable object 1 is going to be the teapot 01, object 2 cup 01, the vector 1 will be the normalized x-axis of the teapot. This is the row 1 of the transformation matrix. The vector 2 is going to be the normalized vector defined by the two positions. And the angle, the inverse of the cosine function of the dot of the two vectors. At this point, the angle between the two is 71 degrees. We can rotate the teapot in the direction of the cup and take the new vector, and the angle is now 9 degrees. Let's make this dynamic. We'll create a watcher object, an independent object, which will have a scripted controller in its, let's say, height track. We'll assign a new script controller, a float script, to this track. Copy parts of the code that we just created into the controller. In addition, and add depends on object 1 and object 2. So whenever we rotate or move some of the objects, this script is going to be evaluated. The vector 1 is still the x-axis of the teapot. Vector 2 is the vector connecting their positions. The angle is calculated using the dot product. And now we can set the wire color of the teapot to a different color. If the angle is less than 10 degrees, then we'll assign green. Otherwise, we assign red. We can evaluate now. And when we start rotating the teapot, its color will turn green whenever it's facing the teacup, and red when it's looking in the opposite direction. Of course, we can do the same with the wireframe color of the second object. So both would change the color. If we would rotate now, both objects change their wire color. Since the node's transformation matrix itself defines a transformation relative to the world coordinate system, it could be seen as a new user coordinate system where the pivot point of the node